Okay, in this video we're going to talk a little bit more in detail about the graphical pipe building method. So let's go ahead and click New Pipeline, choose the graphical pipe building model, and opens up Pipe Graph. Let's go ahead and select some units first. Let's choose English units. Let's say the distance in miles and the flow rates in barrels per hour, say, and pressure PSI, temperature, degree Fahrenheit, and the pump curve units. We'll just leave it as it is. So let's start off with a pump station here and a pipeline segment, another pipeline segment, and let's build up a few of these pieces here. Okay, at this pump station we're going to put in starting flow rate, drop that Q there, and I'm going to go there and double click on this, put some properties. Let's say the station is called Compton, one pump, and suction pressure is 50 pounds, TBD pump curve 2000 horsepower. Just leave everything alone. As far as the flow rate is concerned, we'll say 5,000 barrels an hour. Let's say the temperature is 70 degrees, and we're going to choose, let's say, diesel as a product. Go ahead and save that. We'll define the pipe segments. First pipe segment, let's say, is 20 miles, 16 inch. Go ahead and save that. And the next pipe segment is, let's say, 32 miles. Go ahead and save that. And this one here is, let's say, it's 24 miles. Go ahead and change some elevation, say 150 feet. Go ahead and save that. And we'll do the same thing with the rest of these. 24 miles, leave it alone. And we'll just leave that alone. And the last segment of pipe is, say, 12 miles. So we defined all the pipe segments and the pump station data. Let's go ahead and drop a valve at the end. And this is still a pump, a bunch of pipes, and a valve. We're going to start introducing some flow rates. Let's take this flow and let's say there is a flow at this location. Okay, we have a flow rate here, and let's say it's an incoming flow rate of say 2,000 barrels per hour. The temperature is, say, 75 degrees, and we pick a product, let's say diesel, and then we're going to move over, get another location here. This time we'll have this as a takeoff, so it's negative. Let's say we have 1,500 barrels per hour coming out of the pipeline, and at this point we don't need to put in a temperature or a product name because it's coming out of the pipeline. If it's incoming, it's a positive number. We need to put a temperature and a product name. Okay, so we have at the beginning a flow rate of 5,000 barrels per hour. At the end of this pipe segment we have 2,000, so we have a total of 7,000. At this location we have 1,500 being taken out, so we have a plus and minus here. And let's look at we're going to go ahead and save this file. So we'll say File, Save As. We'll call this test pipe 102 as the project file. We'll save that. Go ahead and quit the application or quit the graphic screen, and then we'll go back into the LIQTHERM folder. I'll just go ahead and save it. So here it is. We're going to open that file into LIQTHERM, and there's LIQTHERM, and go ahead and open that file, which is, well, I guess I did open it. So there it is. So we have flow rate 1 at this location, flow rate 2, Compton is the starting point. So let's look at the flow rates. Okay, at 0 is the starting point. We have 5,000 barrels per hour, positive incoming 70 degrees diesel. At milepost 20, we have an additional flow coming in, positive number, 2,075 degrees diesel. Milepost 76, we have that takeoff, 1,500 barrels per hour. Go ahead and confirm that. Go to the pump stations. We see we have a station at the beginning, Compton, 75% pump efficiency, 50 pounds of suction pressure. Update that. Go to the pumps and drivers, and again we have a TBD pump to be determined, 2,000 horsepower, and so on. We'll go ahead and save that. Let's run this within LIQTHERM. Okay, we got a warning message. For some products, you've entered identical pairs of values of specific gradient viscosity, and for isothermal it's okay, so we'll just click OK. The warning message is basically reminding you that the diesel properties in the database are only for one set of temperature. That's okay for isothermal, because we're going to run isothermal calculations with diesel. I'm going to make sure the MAOP is checked, means we want the program to take into account the MAOP of the pipeline, which happens to be 1400 in this case. And with that information, we're going to simulate this run and go ahead and calculate. Okay, so LIQTHERM ran, and it tells you 3799 is the inlet flow rate, and the outlet flow rate is 4299 because of the pluses and the minuses. Let's go take a look at that. Pump station, there's one station at Compton, 50-pound suction, almost 1400 discharge, and so on. Interesting thing here is it is determined that the Compton pump station requires a pump with a flow rate of 2659 GPM and a head of 4271 feet. So basically it tells you what kind of a pump curve we need. That's the pipeline profile data, velocity, Reynolds, and pressure drop, and you got a temperature and pressure profile. So it starts off at 50 pounds, suction pressure goes up to about 1400, which is the MAOP, and then at the delivery point, 114 miles away, it's 50 pounds. Okay, let's look at the hydraulic gradient, and it's pretty straightforward. You got the different slopes of this hydraulic gradient because of the different flow rates. We have additional flow coming in at milepost 20, and then some flow being taken out at this intermediate location. So basically we have simulated this pipeline starting with the graphical model building within the pipe graph module. In the next video we will look at adding branches and pipe loops in the graphical interface.